Hello, folks. Today I am going to teach you sequence and series. So we are going to learn one topic of sequence and series, that is AP. So before that, let's begin with the funny code. Only algebra can ask you to take 5 things out of 3 and then calculate the remainder. Yeah, that was funny. So let's begin with my intro. About me, I am Rishabh Namdev, a budding chemical engineer, and I am passionate about teaching and sharing my knowledge. You can contact me through my email address, that is 20rishabdev@gmail.com. So let me give you the overview of the lecture. The topics which we are going to study in this video about sequence and series. What is sequence and series? Arithmetic progression, nth term of an AP, common difference D, sum of n terms of an AP. So let's begin. What the first question which comes in mind is, what is the difference between sequence and series? Obviously they are not the same thing. The list of numbers written in a definite order is called a sequence or progression. So we, by first line, we come to understand that sequence and progression are same thing. The sum of n terms of an infinite series is called infinite series. A sequence can be defined as a function whose domain is the set of natural numbers. Therefore, sequence is an ordered list of numbers and series is a sum of list of numbers. Suppose we considered a sequence of natural numbers, that is 1, 2, 3, 4, 5, 6, and so on. This is a sequence. And if we replace the commas by the addition sign, plus sign, that is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 and so on, this is a series. uh, Now, arithmetic progression. If in a progression the quantities increases or decreases by a common quantity, then they are said to be in arithmetic progression. Let's clear it by an example. 3, 5, 7, 9. If we find the difference between second term and third term, that is 5 and 3, the difference between 5 and 3 is 2. The difference between 7 and 5 is 2. The difference between 9 and 7 is again 2. Let's take another example. 24, 20, 16, 12. So here we see that the difference between second and first term, that is 20 and 24, it is 4. The difference between 16 and 20, that is the third term and second term, it is again 4. The difference between 12 and 16, that is the fourth term and third term, is again 4. So we find that the difference between two consecutive terms is 4. So the general form, we have a general form of writing an AP, that is a plus D. We denote third term by a plus 2D, fourth term by a plus 3D, and nth term by a plus n minus D. So here a is the first term. It is a general convention or notation that we denote the first term by a. It's up to you. You can denote it by any variable. And D, here we denote D is the common difference of an AP. The difference we here find in, suppose we consider an example, this one, 3, 5, 7, 9. So here we find that the common difference is 2. And in this series, in this sequence, we find that the common difference is -4. So how to identify an AP? Hence, we can say that the succession of number terms if is an arithmetic progression if the difference between any two numbers consecutive terms is always constant. Our next topic is nth term of an AP. For an AP with common difference D, we have a formula which is, and this is the formula enclosed in the bracket, an, that is the nth term, is equal to a plus n minus 1 D. Here a is the first term and D is the common difference and n is the term which we have to find. Let's clear it by an example. Find the 74 term of the series 3, 7, 11, 5. So here is the solution. So let's begin. Here we have the first term as 3. This 3. Common difference, how to find the common difference? You have to consider two consecutive terms. Suppose I consider 7 and 3. Subtract second term from the first term. So what we are gonna get when we subtract the second term, that is 7, and 3, we are gonna get 4. We can find the common difference from third and second term also, but what we have to remember is you have to subtract the next consecutive term from the first term. That is, if you subtract 3 and 7, you get -4, but that's not true. That's not the common difference. You have to subtract the following terms with the previous one. So the following term here is 7, and the previous term is 3. So what we are going to get is common difference is 7 minus 3, 4. Now what's the value of n? We have to find the 74th term. So here the value of n is 74. Now by the formula we have this t74 is equal to a, that is the first term, plus n minus 1 t. So putting the values, a which is 3 plus n which is 74 minus 1 into d, the common difference. So what we are going to get is t74, that is the 74th term of this series is 295. Let's take another example. Find the 19th term of the progression 5, 9, 13. This is our first part of the question. Is 115 is a term of progression? So we have to find the 19th term, and we have to check if 115 is a term of a progression or not. So the solution, using the formula of the nth term, which is Tn equal to a plus n minus 1 d. Here we have to find 19, so our n is 19. First term is 5, and the common difference, which is 4. How are we going to find it? 9 minus 5 or 13 minus 9. So 4, and by solving this we get our 19 term as 77. Now the second part of the question, is 115 a term of the progression? How we will going to do it? Now we will assume that 115 is the rth term of an progression. We are assuming that 115, that is 115, is a term of progression. So we are applying the formula tr. So in the formula we have tn. Okay, so now it is n for us. Here n is equal to r. So using the formula, our rth term is 115, that is we have considered, is equal to first term plus r minus 1, 4. Now what we are going to do is we are going to find the value of r, which we get as 114 by 4 is equal to 28, 1 by 2. Now here we see that r denotes the number of term, so it can't be a fraction. Are you getting my point? R is r denotes a number, so it can't be fraction, and what we are getting here r is 28, 1 by 2, which is a fraction. So obviously, hence 115 is not a term of progression. Our next topic, nth term of an AP from the end. The previous topic was nth term of the AP from the beginning. Let A be the first term and D be the common difference of an AP having m terms. The nth term of an AP from the end is m minus 1 plus 1th term from the beginning. So the number of terms in this AP is m, and the nth term from the end is m minus n plus 1 term from the beginning. So the formula for the nth term from the end is equal to a m minus n plus 1th term and a plus m minus n plus 1 minus 1 bracket into d. So what we are going to get is nth term from the end is this one, a plus m minus n d. Now another method of finding the nth term from the end is, so what we are going to consider is, suppose we have an AP 1, 2, 3, 4, 5. That is, first term is 1, last term is 5, and the common difference is 1. What we will do is, if we want to find the second term from the end, what we will do is we will consider the AP from in a reverse order. So now what our AP becomes is 5, 4, 3, 2, 1. Now we will reverse the sign of D. That is, now our common difference is 4 minus 5, that is minus 1, and the value of n will be 2, because we have reversed the order. So what will the formula will be am plus n minus 1 into minus d, and here am is the first term and the common difference is minus d. So let's clear it on by example. Determine the number of terms in the AP 3, 7, 11, and the last term is 407. The second part also find its 28th term from the end. We see that it's an AP 3, 7, 11, 407, and the common difference is 4. That is 3 minus 7, 11 minus 4, all have a common difference which is 4, and the first term is 3. The last term, that is an, is equal to 4. We don't know the number of terms in AP, in this particular AP, so we denote the last term by an, which is 404. Now the problem is we have to find the number of terms. So how we are going to use the formula of nth term of an AP, which is Tn is equal to a plus n minus 1 d. Substituting the values here, Tn, that is 407, the last term, then a is the first term 3, and n we are going to find it, and d is the common difference. So on putting the values we get n is equal to 102, and that is number of terms in this particular AP is 102. Now this, the second part of the also find the 28th term from the end. So what we are going to do is using the formula. So we are gonna, what we generally do is we find what is the 20, what the 20th term corresponding from the beginning is what. So what we do is 102 minus 20 plus 1 term from the beginning. So the 20th term from end is 83rd term from the beginning. So we are gonna find using the general method, general formula for nth term, that is T83, a plus 83 minus 1 d, and what we get is T83 is equal to 331, or the 20th term from the end is 331. Method 2. Now we consider the AP from the end, that is we reverse the order of the AP. So what we are going to get is 407, 403, 11, 7, 3. So from here our first term becomes 407, and the common difference is minus 4, because so when we consider the AP from the reverse, our common difference changes. That is, when we find the common difference, that is the second term, which is 403 minus the first term 407, we get minus 4 as our common difference. So now we are going to directly find the 20th term. So T20 is equal to first term, which is 407 plus 20 minus 1 into minus 4. So what we are going to do is T20 as 331. From both the methods we are getting same answer. So you can, any method which you. Now our next topic is sum of n terms of an AP, which we are going to denote by Sn and in the subscript. So the first point is sum of n terms of an AP. What is the general way of writing the sum of n term? So which is Sn is equal to first term plus second term plus third term and so on up till nth term. So what we get as a formula for nth term of an AP is, this is the formula enclosed in the bracket. So Sn is equal to n by 2 bracket 2a plus n minus 1 bracket close into d. So here a is our first term, d is the common difference, and n is the number of terms in AP. All these three variables are familiar to us because we have discussed this previously. See, we have another formula also. Suppose if a and an, that is the first term and last term, are known, but the common difference is unknown, d is unknown, then we, how can we find the Sn? We can use the formula Sn is equal to n by 2 bracket a plus an, that is n by 2 first term plus last term. So both the formulas can be used according to the requirement of the question. Now let's find the Sn for given example. Find the sum of natural numbers between 250 and 1000 which are divisible by 3. What we get divisible by 3 is, that is remainder is 0. So we can find that the number of terms which are exactly divisible by 3 between 250 and 1000 are 252, 255, 258 and so till 999. See, we see that 252, 255, 258 are multiples of 3. So obviously they will form an AP and the common difference will be 3. So first term is 252 and the last term is 999, and D is 3. Now the we are going to find what is the number of terms in this AP. So Tn Tn is equal to A plus n minus 1 D. So our last term, that is last term is 999, is equal to first term 252 plus n minus 1 into common difference 3. Here we obtained the 3, n is 250, that is number of terms is 250. Now using the formula, second formula we have, when D is unknown, Sn is equal to n by 2 first term plus last term. So S 250, that is we have 250 terms, 250 by 2 first term into last term, we get the sum as 556,375. So this is all from the video. If you have any doubt, contact me through my email address that was given in the beginning. Thank you very much.